Have you ever stopped and wondered where something like ChatGPT actually came from? I mean, it really feels like it just appeared out of thin air, right? But the truth is, the entire modern AI boom, you can trace it all back to one single game-changing research paper from 2017. And today, we're going to break that paper down. It's called Attention is All You Need. So let's get into it.
So to really get why this paper was such a massive deal, we have to start with a really basic question. How does a machine even learn to read? How does it look at a sentence and figure out what it all means? Well, for a long, long time, the answer was surprisingly human.
For years, the best AI models read just like you and I do, sequentially. They'd process the first word, then the second, then the third, and they'd try to carry a little bit of memory from one word to the next to build up some context. The problem was this created a huge, massive bottleneck that was seriously holding the entire field back.
And that gets us right to the heart of the problem that everyone was trying to solve. This was it, the big one, the sequential bottleneck.
Right, so these models that did this one word at a time thing were called recurrent neural networks, or RNNs for short. And the idea, it makes a lot of sense. If you have the sentence, I threw the ball, it was red, to understand the word it, you have to remember the word ball. But what happens if ball was 50 words ago?
Now this table, this is straight from the paper, and it shows the problem perfectly. For a recurrent network, the number of steps it has to take, this O of n thing, it just means that the number of steps grows with the length of the sentence, n. So a longer sentence means more steps, and it means information has to travel a really long way. Now look at self-attention. The number of steps is always 1, constant. It doesn't matter how long the sentence is.
And that was the killer issue. The longer the text got, the more the model would essentially forget what it read at the beginning. This has a fancy name. It's called the problem of long-range dependencies. And it was a huge wall. You just can't translate a long paragraph if you've forgotten the first sentence by the time you get to the end.
Okay, so this is where our story really kicks off. A group of 8 researchers from Google came along and proposed something that honestly seemed completely nuts at the time. They were about to throw out the entire rulebook.
This right here? This is the core thesis of the paper, and it was an absolute bombshell. They said, we've got a new architecture. It's called the transformer, and we are getting rid of that whole one word at a time process, completely. Instead of recurrence, they were going to bet everything solely on a mechanism called attention.
So what on earth is this magic ingredient, self-attention? Well, think of it like this. It lets the model, when it's looking at just one word, to also look at every single other word in the sentence at the exact same time, instantly. It can just see how important every word is to every other word, no matter how far apart they are. It doesn't have to remember anything down a long line. It just sees the whole picture, all at once.
And this just lays it out so clearly. We went from a slow, single-file line of words to this massive parallel free-for-all where every word can talk to every other word instantly. This doesn't just fix the forgetting problem, it completely obliterates it. And because it's parallel, you can train it like lightning on modern hardware like GPUs.
Okay, so this idea is pretty radical, right? But how does it actually work? What does it look like? Let's pop the hood and take a look inside the transformer. So this is the official blueprint from the paper. On the left side, you've got the encoder. Its job is to read the input sentence, let's say in English. And on the right, you have the decoder, which spits out the new sentence, say in German. Now this basic encoder-decoder setup wasn't new, but what they put inside those boxes, that changed everything.
And this is the beating heart of the whole thing, multi-head attention. See, instead of having just one attention mechanism looking at the sentence, the transformer runs a bunch of them in parallel. The paper used 8. It's kind of like having 8 different experts all reading the sentence at the same time. One might be looking at grammar, another one's focused on the meaning of pronouns, and then they all get together and combine what they learned.
So to put it all together, here's the flow. First, the encoder just inhales the entire input sentence all at once. It uses that multi-head attention to build this super rich map of how all the words connect. Then, the decoder starts to build the new sentence word by word. And for every single new word it writes, it looks back at the encoder's map and asks, okay, which of the original words are most important for me right now?
So a brilliant idea is one thing. A cool diagram is another. But the real question is, does it work? And this is where the paper went from just being interesting to being legendary. The results were, and I'm not exaggerating, absolutely stunning.
On the main test for English to German translation, the transformer smashed the previous record by over 2.0 blue points. Now you have to understand, in this field, people fight tooth and nail for improvements of like 0.1. A 2-point jump wasn't just a step forward, it was an earthquake.
And here's the kicker. It got that record-breaking score after training for just 3.5 days on only 8 GPUs. The paper itself says this was a small fraction of the training cost of the models it just beat. So it wasn't just better, it was way, way faster and cheaper. A total game changer.
Just look at the official table. The transformer, a single model, hits 28.4. The previous best models were barely breaking 26.3, and they had to combine multiple models together, it's called an ensemble, to even get that score. So a single transformer didn't just beat another single model, it beat entire teams of them working together. This was a total mic drop moment in AI research.
The shockwaves from these results went way beyond just making better translations. It kicked off what you can only really call the attention revolution.
You see, what these researchers had built wasn't just a new tool. It was a new foundation. It was a brand new fundamental building block for AI, a super efficient, super powerful way for machines to understand any kind of sequential data, not just language.
And that foundation, well, it's what basically everything is built on today. The T in GPT? Yeah, that stands for transformer. The massive language models that power our search engines, the AI that finishes our code, even the tools helping to discover new drugs, they are all direct descendants of this one single architecture from 2017. The AI that you use every single day started right here.
The paper made this incredibly bold claim: attention is all you need. And you know what? They were right. And it completely changed the world. Which really just leaves us with one final thought. If that one simple, powerful idea was the key that unlocked this AI revolution, what's going to be the key to unlocking the next one?